In the previous section, we notified the FPGA VI of an event from the host VI using a Boolean flag. By the end of this module, you will be able to notify the host VI of one-time or infrequent events from the FPGA VI using interrupts. So what is an interrupt? An interrupt is a physical hardware line to the host that the FPGA target can assert. So one of the use cases for using interrupts is if you want the FPGA VI to notify the host VI of one-time or infrequent events that happened on the FPGA. For example, you can have the FPGA notify the host when the FPGA has started or is ready. You can also notify whether a task has finished on the FPGA, or a trigger occurred, or an error occurred. So when you want to notify the host of this from the FPGA, what you would do on the FPGA VI is generate an interrupt. When you're using interrupts, they use a method that minimizes CPU usage on the host processor, but there is a little latency that's associated with using interrupts. Okay, so let's talk about the FPGA VI. So on the FPGA VI, if you want to notify the host that something's happened, then what you would do is you would use the interrupt VI to generate an interrupt. So over here, if we look at this block diagram, we have the interrupt VI, and we have an IRQ number that's going into it. So that IRQ number is associated with the logical interrupt that you want to assert. And in this case, we're choosing 0. Okay. On the first bullet, notice that you can choose anything between 0 and 31. Okay. So we also see that there is an input there called wait until cleared. So what will happen if the wait until cleared is set to true is this. So first, it would generate an IRQ on 0. And then it would have to wait until the host has acknowledged it, and only after the host has acknowledged it, then the interrupt VI would go ahead and continue. What I just described is what would happen if wait until cleared equals true. One other thing to keep in mind is that the interrupt VI becomes a shared resource if you use more than one, and therefore it'll induce some jitter if you're calling it in two places at the same time. Okay, so on this slide, let's talk about interrupts and how to handle them on the host VI. So the host VI can wait on and acknowledge interrupts. Okay, so let's say we're in the host and we're waiting for the FPGA to generate an interrupt on 0. So what you would do on the host if you're waiting for that to happen is you would put this wait on IRQ method here, and then you would specify which IRQ you're waiting on. So for example, on what I described, we would just put in 0 into IRQ number. Okay, and that's going to specify the logical interrupt or possibly an array of logical interrupts for which this function waits. Notice that there's also a timeout input and also a timed out output if you want to get that information. And then lastly, that last one is saying, okay, well, once we waited on here, what IRQs have been asserted? And you can get that information as well. On this slide, we see the acknowledge IRQ method. So this is a method that you would use on the host VI after you use the wait on IRQ method. So the way that this would be used is first you would have the wait on IRQ method, and it's waiting on, let's say, IRQ 0. And then once IRQ 0 has been asserted, then the wait on IRQ method will know that that's happened, and then it's going to keep going. And then you would call the acknowledge IRQ method. And then here you would acknowledge that IRQ 0 has been received on the host, and that way you can use this acknowledge to let the FPGA VI know that the host has received it. Okay, so let's walk through this example, and we can see one example of how these interrupts work on the host and FPGA VI. So in this case, what we're trying to do is we're trying to synchronize the start of the code in the host and the FPGA to start at the same time. So those two blue blocks there of code, we want those to start executing at the same time. So let's take a look at the FPGA VI first, since it's faster. Okay, so let's say in the FPGA VI, we have an interrupt VI there in the first frame. And what we're doing is we are asserting IRQ number 11. And we also have wait until cleared equal to true. So when we get here, what's going to happen is the FPGA is going to assert IRQ number 11, and then it's going to sit there and wait until IRQ 11 has been acknowledged. So let's go to the host VI. In the meantime, the host VI is starting up, and then it gets to the wait on IRQ method. So once it gets to the wait on IRQ method, it's looking for 11 to be asserted. In this case, we know 11 has already been asserted by the FPGA VI, So then it's going to go on to our next function. And then notice that IRQ asserted is going to output 11 as well. And then we're going to go to the acknowledge IRQ, and then we're going to say, okay, now we're acknowledging IRQ 11 has been asserted. At that point, then on the FPGA VI, because it's been acknowledged, the interrupt VI can finish executing. And now the two sections of blue code that you see on the host and on the FPGA are going to start at the same time. Now you can notify the host VI of one-time or infrequent events from the FPGA VI using interrupts. Next, we will implement an FPGA watchdog.